Introduction to System Software and Hardware. Components of hardware are the CPU, memory, and I/O. Hardware is surrounded by a software abstraction. Why? Because it's too complex and time-consuming to deal with efficiently. Software abstraction makes it easier to work with. Binary code runs the inner circle, the hardware. Assembler language programming code made it easier to work with the hardware, but assembler language was still difficult. And assembler had to be translated to binary. A special program called an assembler did this. Other languages followed later, like COBOL. COBOL was a high-level language. It consisted of program statements that you'd key in. The high-level code had to be translated to binary code. Compilers would do that. High-level language to binary translation requires a compiler. Low-level language to binary translation requires an assembler. Then these came along, interpreters. They would translate high-level language statements one line at a time and execute them. Also, one line at a time. There are C, C++, Visual Basic, and Pascal compilers, and many more. They translate from their language to binary code. These compilers are made by the manufacturer and not the programmer who uses the high-level language. The system, as a definition, has now expanded. It's now CPU, memory, I/O, and now language, encompassing compiler and interpreter. These languages allow programs that do work to be created by who? By programmers. Word processors, database systems, CAD/CAM programs, and games. So all these are programs, and they perform a type of work, and they're made by programmers, and they expand the definition of the system. They become part of the system. We mentioned I/O before. What is that? Printers, monitors, keyboards, mouse. These let you put data into and get data out of the PC. How do these devices work? Well, programs are written that teach the PC how to understand that device, how to work with that device. Such programs are called device drivers. They too are now a part of the system. Integrating all the drivers and useful user programs together into a single cohesive whole is the operating system. We have seen DOS, Windows, Linux, and Mac operating systems since the late 70s and early 80s. As more hardware is added and updated, more software drivers are required, further adding to the complexity. Complexity of what? Of the operating system. Let's talk about programmers again. And programmers write in high-level languages usually, and that is converted to binary code for PC execution. A program, what the computer programmer writes in his text editor, pre-compilation, before he compiles it, is also known as source code. After it is compiled, the result is called object code. This code is placed into files on the disk. Ergo, the terms source file and object file, or OBJ file. Print out your program statements onto the printer, and that is called a program listing. So we have hardware, layers of operating system software and drivers, and application software. We also have device manufacturers who create newer components. and programmers who create applications, drivers, and operating systems, thusly deepening the complexity. And that's the end for now. Logically yours, George Boole.